Hey guys, Mrs. Traver here. We're going to do our notes on section 6.5. This is linear inequalities. So the game plan here, first off to notice, is that this front side is section 6.5, the back is 6.6. This will be one video, the back will be a separate video. So let's kind of look through the title a little bit more. It says linear inequalities. So first off, notice that linear means we're going to have a line. So that's an important first note. So first, the very first step we need is to graph that line. So that'll be the first big thing. And then the second thing I want to remind you of is that we've got these inequalities less than or equal to and greater than or equal to. And these are past notes where we did it with one variable, where like we had something like x is less than or equal to 2, and you graphed it on the number line. You had like a closed dot at 2 and you shaded to the left, for example. It's the same kind of idea, but that was in one variable. So it was just a number line. Now we're doing lines which have the coordinate plane with two number lines, basically. So we're going to be graphing that line and then shading the same kind of idea way. So just like before, where we had less than or equal to, greater than or equal to was a closed dot. If we have the same symbols, less than or equal to, greater than or equal to, it should be a bold line. And if we have the other ones that we previously used an open dot for, less than or greater than, it should be a dashed line. So that's the first big thing. That corresponds to the closed dot and the dashed line. So like you can kind of remind yourself that it was like that before with one variable. Now we have two variables though. So after you graph your line, you either dashed it or bolded it. Then we need to figure out which side we shade. So you can kind of imagine like we've graphed some line. And are we going to shade this side or are we going to shade this side? And to do that, what we'll do is we'll pick some point. Really kind of any point as long as it's not on the line. So pick any point over here or any point over here and we'll test it. And so we'll try that out, but we'll pick a point to check. And if it's true, if we get a true statement, then we will shade that side. And if we get a false statement, then we won't shade. So that'll be kind of the game plan. Let's first start off with something kind of straightforward. So this is the checking part of it. So say we had this line, y is greater than x plus 7. Kind of looks like y equals mx plus b, but not an equal sign. And we're checking to see if 3, 6 is a solution. So 3, 6 is a coordinate pair, x comma y. And so I can basically plug the 3 into the x and the 6 into the y and see, is that true? Let's simplify the left or the right side. The right side is 10. So now I've got 6 greater than 10. Is that true? That's false. So because it's false, is it a solution to the inequality? False, don't shade, so it's not a solution. All right, let's check out another one. This one is same situation. We've got a point and some function. We're going to check and see if this x, y fits into this equation. So let's plug the negative 5 into our y. I'm going to write it over here. 3 times x. So 3 times 1 minus 2. Simplify the right side. 3 times 1 is 3. 3 minus 2 is 1. So is negative 5 less than or equal to negative 1? That's true because the negatives are always less than the positives. So true. So yes, it is a solution. I forgot to write over here, not a solution. All right, so that's the checking part of it. Let's start one off from the tip top. So we've got a line, y is less than or equal to, zoom in a little bit, y is less than or equal to 1/2 x plus 1. So we're going to first graph the line like we normally would. So like we're in y equals mx plus b format. So our b is 1. Put a point at the y-intercept. And then we're using our slope, rise 1, run 2. Rise over run. Rise over run. And I can go backwards 2. There we go. Before I draw my line in, let's think we are in less than or equal to. So it's an or equal to. That means we would have done a closed dot or we could have done a dash, a bold line, sorry. So I do want to color in this line. I don't literally mean you have to like color it in. Just the fact that it's it's connected, I guess, is what I mean by bold, as opposed to dash. So that's good there. Now we're at the checking part of it. So we want to pick a point to check, and we can pick any point as long as it's not actually on the line. Because like if I check 0, 1, I already know what's happening there. So pick any other point. Pick the easiest point you can think of. And the easiest point I can always pick, if it's available, meaning like if it's not on the line, is 0, 0. That's a nice point to check. So we're going to check that point. I'm going to circle it so we can see it. So we're going to check 0, 0. And so what I mean by that is 0, 0 a solution to this inequality? So plug it in like we did before. So x is 0 and y is 0. So I've got 0 less than or equal to 1/2 times 0 plus 1. So I can get rid of that. I've got is 0 less than or equal to 1. That's true. And we said a true statement is that we shade that side. So this is the side that I want to shade. You can shade it as much or as little as you want. I kind of get lazy and just do scribbles to get the idea. But there we go. That is a linear inequality. Let's do a few more. So here's the next one. We've got y is greater than negative x plus 2. We're going to graph the line like normal. So y-intercept is at 2. So go up to positive 2. And then our slope is hiding right there. Our slope is negative 1. So our slope is negative 1 over 1. So down 1, right 1. Down 1, right 1. All right, and then let's see, we've got a less than symbol or a greater than symbol here. So this is going to end up being a dashed line. So we can kind of see where this is heading. I'm going to dash through it all. There we go. Let's check a point. So 0, 0 is available. Let's check that. If I plug it in, I'd have 0 is greater than negative 0, which is just 0, plus 2. So is 0 greater than 2? That is false. So on the side where there's 0, 0, I am not going to shade. So shade the other side. All right. Hopefully we're getting the hang of these. Let's do another one. Get this out of here. Let's see. Intercept at negative 4. Slope is 3. So up 3 over 1. Up 3 over 1. Up 3 over 1. It's going to be a dashed line since there's no or equal sign. And then let's check a point. Again, 0, 0 is available. So let's use that. I'd have 0 is less than 3 times 0 is 0. So that goes away. Is 0 less than negative 4? That's false because negatives are less than 0. So we're not going to shade on this side. Shade the other side. All right. I'm going to leave the last one for us to finish up, and then we'll be all set. So again, 3 is our y-intercept, so pop the point in there. And our slope is negative 2, so down 2 over 1. Down 2 over 1. We've got less or greater than or equal to, so that's a bold line. And then our shading is the last point. 0, 0 is a variable, so we can use that. If we can't use 0, 0, by the way, like some of your practice goes through here, so we can't pick that point. We could pick any other point. Pick an easy point for you. So maybe pick like, I don't know, maybe we'll pick 2, 2. You could check that just to try a different one. But if we check 2, 2, we have 2 is greater than or equal to negative 2 times 2 plus 3. Some simplifying here. Negative 2 times 2 is negative 4. Negative 4 plus 3 is negative 1. So is 2 greater than or equal to negative 1? That's true. So I checked this point over here, and it's true. So I do want to shade that side. All right, that is it for these notes. I hope that this worked out. We're going to do some practice of this stuff tomorrow in class. See you then.